Hi, Math 3 students. Today we're going to continue talking about different ways that you can use Desmos on the SAT to answer some of the questions. One really big advantage of Desmos is it's really easy to take a function and identify the minimum values, the maximum values, the x-intercepts, and the y-intercepts on Desmos. Yes, you can do this via graphing calculator, you can do this by hand, but of course it is nice to know how to use Desmos in case you forget how to, algebraically do it by hand. So let's go ahead and walk through that here. So if we look at number 14, it says Khadijah launches a toy rocket from a platform. The height of the rocket in feet is given by h equals negative 16t squared plus 56t plus 120, where t represents the time in seconds after launch. What is the rocket's greatest height? Okay, so one important thing that you kind of just have to know from this is what your input's going to be and what your output's going to be, right? If you notice, t is pretty much in the place of x, right? And then h is in the place where y usually is. So our input is time, and our output is height, all right? So when we get our coordinates, the x value, the thing that comes first that's in that x value spot is going to be your time in seconds, and the h is going to be your height in feet, all right? So we can go ahead and plug this function in. We say that h is equal to negative 16t squared plus 56t plus 120. All right, and it goes ahead and it graphs the function for us, which is very nice. And as you can see, we have the graph here that is representing the rocket, right? And they're asking us, what's the rocket's greatest height? Okay, so we can see the rocket's path here. One nice thing on Desmos is you can very easily change your the X and Y scale, specifically like the window that you're looking at. So let's see, if I make this like my X window -1 and my Y window, I don't know, we'll go like 20. It kind of makes the graph a little bit prettier to look at. As you can see, it was like really tall and skinny, so I just kind of widened that the X axis there, so it kind of zooms in. That is totally not necessary, but it just makes it a little bit prettier to look at. All right, so they're asking, what's the rocket's greatest height? Well, we can see that the rocket's launched right here. It's going to hit its greatest height there, and then it's going to hit the ground over here. Now, normally, it takes a little bit of effort to get these values, but Desmos just spits them right out to you. So we can see that it's going to hit its greatest height here at the maximum. So it hits it at 1.75, comma 169. So if we recall, the height in feet is going to be our y value. So the greatest height here is going to be 169 feet. All right. All right, let's try another one here. So for number 15, we have a different function here. We have h of t. I think it should let us plug it in like that. Let's see, h of t equals negative 16t squared plus 1156. All right, so again, we have our function here, okay, and you can see that we have like our maximum values, we have our minimum values, or actually no minimum. We have our maximum values and our intercepts that we can very easily see here, okay? And it says a tennis ball is dropped from a certain height. Its height's given by this function, where t represents the time in seconds. How long was the ball in the air? So you could see that this one wasn't like launched up, right? It was just literally dropped. And if we look at the intercepts, right? When they say how long is the ball in the air for? Well, it's going to be in the air from t equals 0, right, until it hits the ground, okay? So we can see here that its height is again 0 at 8.5 seconds, okay? So that means that when your height's 0, right, you're hitting the ground. And that happens at 8.5 seconds. So how long is the ball in the air? For 8.5 seconds. All right. The next one, it says Brianna kicks a football. Its height is given in feet, where t represents the seconds after the kick. How many seconds have gone by when the football is at its highest point? So go ahead. I want you to try this one. plug this one into Desmos, and they're asking about the highest point. So go find the highest point, and specifically they're asking about seconds. Remember, seconds is your x value. So essentially you're finding the x value at the highest point. So go ahead, plug that one into Desmos, see what you can find. So when you plug this in, we should get h of t is equal to negative 16 t squared plus 80t. All right. And if we zoom in, right, we can see that it's going to hit its highest point at 2.5 comma 100, which means that at 2.5 seconds is when it hits its highest height of 100. Now this question specifically just asked about the seconds, so it would be 2.5 seconds. All right, so the next one we're going to go ahead and try is dealing with data sets. All right. Now, again, your graphing calculator, your TI-84 can do this, but it's just nice to know how to do it on Desmos. All right. So Desmos is able to calculate both the median and the mean and quite a few other like statistical values from a set of data. However, you need to know how to plug in a set of data. So on Desmos, the way you plug in a set of data is first you have to make a set. I recommend just using the letter A as your set value. So you're going to say A equals, and then you have to use the boxy brackets. All right, not the parentheses, those, you got to use the boxy brackets. On your keyboard, that should be like right above your enter key. Or you could always just do it straight on the Desmos keypad. All right, so they gave us our data set here, so you need to plug in your data set. You separate your values with a comma. So here we would do 5, comma, 42, comma, 24, comma, 43, comma, 34. And then we go ahead and close our bracket there. So one nice thing about Desmos is it tells you how many elements you put in the list. So you can see that I entered in 5 elements, and you can see 1, 2, 3, 4, 5. I had 5 elements to begin with. This becomes very helpful when you have like a lot of values that you're plugging in, and maybe you plugged one in wrong. I know that I personally have put a period in instead of a comma, and then it reads 2 numbers as 1 number. So it's nice to double check that you have the appropriate number of elements. So on Desmos, there's a couple of different ways that you can find the median and mean. You can just straight up type it in. If you type in MEAN, oops, and then if you do open parentheses, and you have to identify the set that you're using. Well, we defined our set as A, so you're going to go mean of A, close parentheses. All right, and as you can see here, it just gives it to me. My mean here is 29.6. And then to find the median, you can just type that in as well. MEDIAN, open parentheses, and then of course we're still looking at set A. We do that, our median is 34. All right. Now, if you, let's say you forget, it's not working, you forget what value or what term you're supposed to type in. If you go to functions and go to statistics, you can also, instead of like typing in mean, typing in median, you could just type that in, or go to functions and click, I should say. And those will all be under the statistics category. It also calculates quite a few values like the total, the min value, the maximum value, quite a few other things as well. And you would just do it the same way. You would click mean, A, close parentheses, and of course it's going to give you the same thing. All right. So again, the way that you can find the mean and median using Desmos is type in your set by doing A equals, using the brackets, putting in all of your values and separating them by commas, and then typing in mean and median of that set. All right. So go ahead. I want you to try number 18. So go ahead, plug in those values for set A, and then ask it to find the mean and median of set A. So we can go here, plug these in, and I'm going to actually just leave mean and median here because we're going to use those again. So we've got 9, comma 2, comma 19, comma 21, comma 39, comma 15, and comma 0. All right, so I'm again going to double check that I plugged in the correct number of elements. I got 1, 2, 3, 4, 5, 6, 7, and that's how many elements I plugged in. You know, it's always a good thing too to just kind of like double check your numbers, make sure you plug those in right. And here we should have gotten for our mean 15 and our median 15. All right. Alrighty. Let's see. So now they are asking us to calculate the mean from a data table here. Okay. So this is actually like a frequency table. They gave us the scores and then the number of students that received that score. Okay. So if we're trying to find the mean value of these, if we want to use Desmos to do this, what we have to do is we have to go and plug all these values in. However, we have to put in the appropriate number of that, right? So like if I had 2 students that got a 65, I need to type 65 in twice, right? So I'm going to do 65, comma 65, and then I've got 5 students who got 70. And then I got 7 students who got 75. 1, 2, 3, 4, 5, 6, 7. And then I got 2 students with 80. And 6 students with 85. 2, 3, 4, 5, 6. And then 5 with 90. 1, 2, 3, 4, 5. And 6 with 95. 1, 2, 3, 4, 5. Oops, 5 and 6. All right. Now, of course, I want to look here and make sure I have the appropriate number, make sure I plugged everything in right. So I can see 2 plus 5 plus 7 plus 2 plus 6 plus 5 plus 6. I should have 33 data points, and that is, in fact, what I have here. I can kind of just, you know, scroll through and make sure nothing looks wonky, because, of course, you type this in quickly, right? So you just want to always double check that you didn't type anything in wrong. All right. So let's go ahead and make sure all of that is good to go. Yep, looking good. All right. So now they're asking for the mean. So I can, of course, I'm going to go to functions this time, just change it up. So I'm going to do mean of A, and it gives me 86.6. All right. And here they did ask me for, they asked me to round to the nearest tenth. All right. So in that case, I'm going to round to the nearest 1 decimal place. So that's going to be 81.666. I cut it off there. This 6 rounds this up. So I end up with 81.7 as my rounded value. All right. So go ahead. I want you to use this frequency table here for number 20 and go ahead and find the mean of these values. All right. So let's go ahead. I'll plug these in. I'm just going to retype it in. It's taken forever. A equals, and then we'll do open brackets. All right, so we've got 565. So we're going to do 1, 2, 3, 4, 5. We've got 4 70s. 1, 2, 3, 4, 5. Oh, we only have 4 70s. Oops. And then we've got 3 75s. 1, 2, 3. We have 5 80s. 1, 2, 3, 4, 5. We have 385s. 1, 2, 3. We have 8 90s. That's a lot. 1, 2, 3, 4, 5, 6, 7, 8. And then we have 6 95s. 6. And 6 100s. 1, 2, 3, 4, 5, 6. All right. Now, of course, I want to make sure that I plugged in the appropriate number of values, right? It tells me I plugged in 40 different numbers. So I'm going to go ahead and add up add up the total number of elements I should have had in this list here, right? So that's going to be 5 plus 4 plus 3 plus 5 plus 3 plus 8 plus 6 plus 6. And I got 40. So that shows me that I did plug in the appropriate number of elements. Again, we're finding the mean. So I'll go to functions, click mean, A. And I ended up with 84.37. So they again told me to round to the nearest tenth. So the 7 boots this 3 up. I get 84.4. And that would be my answer here. Now with frequency tables, sometimes using this feature on Desmos may not be the quickest way to do it. All right, so I am going to show you, in my opinion, like a quicker way that I would do something like this, where I'm plugging in multiple values. Like 5 of 65, 4 of 70. So another way you can do this from a frequency table would be just doing, okay, instead of doing like 65, 65, 65, we're going to actually like calculate the mean by hand. So if you recall, the way that you add or you find the mean is you add everything up and then divide by the number of things you added up, right? So we can do 65 times 5. So instead of doing like 65 plus 65, 65, 65 plus 65, we just do 65 times 5. And then we'll do 70 times 4 plus 75 times 3 plus 80 times 5 plus 85 times 3 plus 90 times 8 plus 95 times 6 plus 100 times 6. All right, so I got 3,375, and then I have to divide that by the total number of values that I added up, which was 40. And you can see here that I got the same number, okay? So I just wanted to kind of give you different ways you can solve this. You might find this method quicker, so absolutely feel free to do it that way as well, all right? All right, so let's go ahead and try number 21. All right, now for this one, we're going to try something called the slider in Desmos. So it's kind of a nifty feature. The SAT loves to ask questions like, what value of K would make this system have one solution? What value of K would make this system have infinitely many solutions? Things like that. And this is another example of a way that they ask a question that's similar to that. And it's saying like, what values of K would result in this function having imaginary roots, okay? So if you recall, with quadratics, you have kind of 3 options in terms of your kind of roots. If you have imaginary roots, that's going to mean that you don't go through the x-axis at all. It means you have no real solution. Sometimes instead of roots, they'll call it solutions. If you go through the x-axis twice, you have 2 real solutions. And then if you go through the x-axis exactly 1 point, that's when your vertex is literally on the x-axis, you have one real solution. All right. So in this case, if we want imaginary roots, that means that we have no real solution. All right. So we're going to go ahead and plug this in. We're going to say 3x squared plus 60x. Oops, sorry. And then plus k. Now, whenever you do a constant like this, you can add in a slider. And what it does is it allows you to change the value of k, and you're going to see that it changes the graph. Okay. Now, If we look here, currently, this function has two real solutions, right? And we're trying to figure out what values are going to give us no real solutions, okay? So if you can see here, right, no matter what value of k based on this range they gave me, I'm still having two solutions. However, you can see that it's moving up when I raise my value of k, all right? So you can change this range of your slider value by just like clicking on it, clicking on like the -10. And I don't know, let's see. We definitely have to make this way bigger. So let's go maybe from like 100 to 400. Okay. All right, so that definitely gives us a better range here. And you can see that we are then starting to get values that give us a function with no real solution. Okay. So what we can do here is we could see what value gives us one solution, right? We can see here when k is equal to 300, we have one solution. That's our one real solution. Anything higher than that, right, that's giving us no real solution, okay? So even if we do, we can change, the k value to like 300.1, okay? When I do that, you'll see we have no solution, right? No real solution, I should say. So basically, any value of k that is higher than 300 or greater than 300 is going to give us a function with no real solution or imaginary roots. All right? Okay, so let's go ahead and try number 22. So again, we're going to plug this in. We've got 2x squared minus 36x plus k. And again, we're going to want a slider for k. We definitely need to zoom out here. There we go. And in this case, it says use a discriminant to determine all values of k that would result in a graph of the equation intersecting the x-axis at two distinct locations. All right. So what that means is they want us to have two solutions. Okay. So if we want two solutions here, you can see here that all of these values right now are giving us two solutions. So let's go figure out what value gives us one solution. And then we can figure out if we want values above or below that. All right. So let's go ahead. I don't know. We'll go again, maybe 100 to 300 here. See what that does. Yeah, it's going to work there, right? So if we go ahead and slide this, oops, come on. Let's see. It's right in there. My fat finger can't move this nicely. Let's see. Maybe if I change this step, we know that that's around, 160. So let's maybe do like 150 to 170. Okay. And that'll allow us to do smaller steps there. Another thing you can do too, like if you want it to be like every 10th or every 100th, I think you should be able to do that, right? Does it let you? Oh no, it doesn't. Just kidding. But you can change it, I think, to be like one step or every 5 or some value. Yeah, so this one's only giving me whole numbers now. So you can go ahead and kind of change that step so that it changes the values of k that it's spitting out there. But anywho, we can see that we end up having exactly one solution when k is equal to 162, okay? If I make k bigger than that, we have no real solution. And if I make k less than that, we're going to have two real solutions. And we want it to intersect the x-axis at two distinct locations. So we want k values that are less than 162, right? Because at 162, we have one real solution. If I go just a little bit less than that, let's say I do 161.9, okay? That's just below it, but we still got our two solutions there, right? We still got our two x-intercepts. All right. So let's go ahead and try number 23. They want this function to be tangent to the x-axis, okay? And what that means when something's tangent, it's just going to touch at one location. So essentially they're saying what value of k is going to give us one real solution here. So let's go ahead, we'll plug this in, and we get 3x squared plus kx plus 192. All right, we can add in our slider here. We, of course, need to zoom. Oh, there we go. All right, so we go ahead and we can edit the values of k here. All right, now as you can see right now, no values are giving me anything tangent to the x-axis here. So let's go ahead, I don't know, let's go maybe negative 200, whoops, negative 200 to 200. Let's see what we get. All right, now we can see here, we can start getting values where we're going to be just touching the axis there, okay? So if we look, we can change x here. So we can, oh my goodness, sorry, I'm getting so many text messages. So we can see that over here, right, we're going to end up having or touching the x-axis once here. Maybe between, let's go like, between, we'll say negative 50 and negative 40. Okay, so if I do negative 50 to negative 40, all right, now if we do that, it gives me kind of a smaller range here, and I end up with a k value of negative 48. All right, so k can equal negative 48 if I want to be tangent to the x-axis. All right, now one thing I want to point out, if we go back, if you notice, when I had kind of this big range here, there were really two values that were giving me one solution. Right over here when k was negative, but if you notice, when I make k positive, it also is going to have one solution at some point here. So let's go ahead and figure out what two values that one's between. So we got 50, and let's do 50 and 40 again. All right, so 40, 50. All right, so we'll go mess around with this, see what value gives us one solution. Oops. All right, so we can see here that we do in fact have one solution. Don't be afraid to zoom in, right? Because sometimes it looks like it's touching the axis and it's not. So don't be afraid to like zoom in. And as you can see here, I do have the function tangent to the x-axis here when k is equal to positive 48 as well. So those are my two values of k that are going to make the quadratic function tangent to the x-axis.